Okay. So we are starting part 2 of the EOT. Okay. Like I said, it is important for us to read carefully, read correctly, reread the question, and also remember we need to know the formula and the theorem. Okay? That we need. Why is this not moving? Okay. All right. So the first question says you have a basketball league, okay? And there must be what? 5 players in the team. Okay. So now, because we need 5 players in the team, it says here, how many different 5-player teams can you make? Okay. So let's read. You have a 14-player team. So in your team, there's 14 people. Okay. Out of these 14 people, 3 are centers. Then you have power forwards. Power forwards. You have 4 of them. Okay. And you have 2 small forwards. Small forwards. Okay. And you have 3 shooting guards. So shooting guards. You have how many of them? 3. The rest are point guards. Okay. So shooting guards, and then you have point guards. Now you need to know how many are point guards. So point guards, you're going to add all these values and subtract from 14. So 14 minus 3 minus 4 minus 2 minus 3, and that should give you 2. So there's 2 point guards. You have to do all that. If you don't do that, that's where the question is getting you, because they know you're going to forget. The rest you needed to find. Okay, so now what does the question ask you? How many different player teams can you make? So just start this using the principle, the counting principle of probability. Okay, so you were gonna do 3 times 4 times 2 times 3 times 2. That gives you 12. That gives you 6 times 2. That gives you 12 times 12, which is 144. And that is your answer. So how many different 5-player teams are possible if one player is selected from each position? 144 5-player teams are possible. Possible, double S. Possible. And you box your answer. Okay. That's how you answer that. Okay. All right, let us move on. Angelica is comparing vacation places in Boulder, Colorado, Sarasota, Florida. Okay, and Sarasota, Florida. In Boulder, she can choose 1 or 2 week stay or a 1 or 2 bedroom suite. In Sarasota, she can choose 1 or 2 or 3 week stay, a 2 bedroom or a 3 bedroom suite, whether it is on the beach or not on the beach. Okay? So here she has 2 options. Here she has 2 options. Here she has 3 options. Here she has 2 options. Here she has 2 options. How many outcomes are available for Boulder? 2 times 2. These are the numbers for Boulder right here. So she has 4 outcomes. How many outcomes does she have for Sarasota? She has 3, 2, and 2, which is 3 times 4, which is 12. Okay, outcomes. Make sure you read carefully. Okay, how many total outcomes? So total means to add. So 4 plus 12, giving us a total of 16 outcomes. You box your answer. Morris packs suits, shirts, ties that can be mixed and matched. Use his packing list to draw a tree diagram. Now here you have to draw a tree diagram, okay, to represent the sample space for possible suit combinations. Okay, so gray. I don't have gray. I'll use, do we have black? Yes. Okay, so I use purple to show gray. So gray, or just write gray. What is this? Black. And what is this? Khaki. Okay, so these are suits. Then the suits go to shirts. So we have 2 shirts. So each one of them gets 2. So what shirt does he get? He gets a white and a light blue. A white and a light blue. A white and a light blue. Okay? Then they break down to ties. You can wear a tie and no tie. So tie, no tie. Tie, no tie. How did I know no tie? Because it said you have an option of not wearing the tie. Optional means not wearing. You can or you cannot. So I told you reading is important. Tie, not tie. Tie, not tie. Tie, not tie. Tie, not tie. And then remember I said you have to have an answer for every part. Every part of your tree diagram, you have to write the answer. Okay? Let me use another color. Let me use blue. So here you will have a gray, a white, and a tie. Here you'll have a gray, a white, and a no tie. Here you'll have a gray, a light blue, and a tie, gray, light blue, and no tie. Okay? You can separate them with commas like that. All right. Here you're going to have a black, a white with a tie, a black, a white with no tie. Then you're going to have a black, light blue with tie, black, light blue with no tie. Here you're gonna have khaki, white with tie, khaki, white with no tie. Here you're gonna have khaki, light blue with tie, khaki, light blue with no tie. And make sure, well, yes, as in label your key. So that will be your G, this will be your B, this will be your K. This will be your W, this will be your LB, this will be your tie, and this one will be no tie. Okay? All right. So that's how you're supposed to do that tree diagram. Tala wears a school uniform that consists of skirts or pants. So these are for wearing down. So you can wear a skirt or a pant. Okay. Then on the top, she must wear a shirt, a blue jacket, a sweater. So lazim shirt, but blue jacket and sweater is or. So it is shirt with blue jacket or shirt with sweater. Okay? Shirt and blue jacket, shirt and sweater. Those are the only combinations you can wear at the top. Okay? Then on the feet, she can wear socks. She must wear socks and shoes. So this is socks and shoes. Okay. Now, let us write our numbers. 3 skirts, 3 pairs of pants, 6 white shirts, 2 jackets, 2 sweaters, 6 pairs of socks, and 3 pairs of shoes. Okay? What does the question want? Find the number of possible outcomes. Okay? So, you have to think. Okay? So, because you said or, you're going to put plus here. So, down, she has 6 different options. Then here, because this is or, you're going to add them. So this will be 6 times 4. And this is and, so you're going to multiply them. So that will be 6 times 3. And then you multiply all of them. Now, I have 6 times 6 times 6, 6 times 6 times 6 times 4 times 3. So this is 6 cubed times 12. And that should give you 2592 possible outcomes. And you box your answer. Okay? All right, we move on. A sandwich shop provides its customers with a number of choices for bread, meats, and cheeses. 3 breads, 4 meats, 5 cheeses. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3. Okay. Provided one item from each category is selected, how many different sandwiches can be made? I will multiply. This is easy. This is 20 times 3. That gives you 60. So you write 60 different sandwiches. 60 different sandwiches can be made. And you box your answer. List 6 different expressions. This is a very good question. List 6 different expressions that could be used to evaluate the area of this composite figure. Okay, so it's saying how many different, I need 6 different ways of finding the area of this. So one way I can do is divide it like this. So I'm going to have rectangle A, rectangle B, rectangle C. Now, what's the distance from here to here? The distance from here to here is x, and the distance from here to here is 2 and 2. So this is x plus 4. So now I'll find total area equals to rectangle 1, area of rectangle A, area of rectangle A plus area of rectangle B plus area of rectangle C. How do you find area of a rectangle? Kanun says area of rectangle is length times width. That's what Kanun says. We have learned this Kanun since grade 3. Okay. Now let's look at rectangle A. What's the length? The length is x plus 4. And I'm going to multiply with the width, which is 2. You can write it like there. Plus, I'm going to look at rectangle B. What is the distance from here to here? Now, I know that the distance from here to here is 2. If I remove 2 from this, I will get x plus 6. So the length of rectangle B is x plus 6, and the width is from here to here, which is 4. Okay, plus this one will be just 3 times 2. So this will be 6. This will be 4x plus 24. And this will be 2x plus 8, because I will do distributive property. Okay? Then I will put my like terms together. So 2x plus 4x, 6x plus, what is 8 plus 24 plus 6? 8 plus 24 plus 6 is 38. 38 square units. So I put this in a bracket and I box my answer. So this was the first way. We need 6 different. So here we're going to do the second way. So notice here I went vertically. So I went vertically. I partitioned my shape vertically. Here I want to do horizontally. So I'm going to do this and this. I'm going to get A B, and C. Now the answer that I get here has to be the same as the answer that I get here, even though the numbers will not be the same, but this last step has to be the same. Okay, so then I will write here total area equals to area A plus area B plus area C. Because they are rectangles, I'll do length times width plus length times width plus length times width. Okay. What is the length of the first rectangle? 2. So 2 times x, and that gave me 2x. Plus, now what's the distance from here all the way here? Already I have 8. X plus 8 is from here to here. This distance is x plus 8. So what is this distance? 3. Okay? So the distance, or I do it here. You can do it here. The distance from here to here will be x plus 8 plus 3. So that will be x plus 11. X plus 11. And then now I want the width, which is this part here. So multiply it by 2. Then now I want to do this one will be x plus 8. And this distance here, which is the width, is also 2. So this will be 2x plus 22 plus 2x plus 16. So I have 6x, 2x plus 2x is 4x, plus 2x is 6x. Then I do 22 plus 16. 22 plus 16 gives us 38. 38, and then you write here square units because you're finding area. Okay, now this answer, as you can see, is the same answer as that. So that was 2. Now we need to do 3. Okay, so 3, I partitioned it like this and here. Okay, like that. And I also did here. So I had 4 partitions. So area A, area B, area C, and area D. So then I write here total area equals to area A plus area B plus area C plus area D. Area A, length times width. Area B, length times width. Area C, length times width. Area D, length times width. After I find all the areas, I will add. What is the length of this part? So we know that this is x plus 4. So that will be x plus 4 times 2 plus area B. What's the distance from here to here? I know that I already have 8, but I'm removing this 2, so this will be x plus 6. So x plus 6 times 2, the width. The distance from here to here is 2. Plus area C, same thing, x plus 6 times 2. Okay? Then area D will be 3 times 2. So this will be 2x plus 8 plus 2x plus 12 plus 2x plus 12 plus 6. X, x, and x. That gives me 6x when I add them. Positive 8 plus 12 plus 12 plus 6. That should give me 38. Then I write square units. And I box my answer. Okay? Then the fourth one, I did subtract. So I found the big, I drew this like this. I connected. Okay. So I said total area equals big rectangle, area of big rectangle minus area of rectangle A minus area of rectangle B. Okay? So length times width minus length times width minus length times width. Okay? So I found this big rectangle and I removed the white parts. Okay? So the big rectangle will be x plus 8 plus 3, which is because this is 3. So from here to here will be x plus 11. X plus 11 will be the length, and the width will be from here to here, which will know you have x and 4 here. So x plus 4. Okay. Then minus here will be, what's the distance from here to here? You have x plus 11, you remove the 2, so x plus 9. X plus 9. Remember, from here to here is x plus 11. Now you want only from here, so remove this 2. That will give you 9. And the width will be x. You multiply with x. Minus, this one is just 3 times 2. So this will be minus 6. This will be minus x squared plus 9x. This will be, here you're going to do FOIL, or that distributive property. So x times x, x squared, x times positive 4, positive 4x, positive 11x plus 44. Okay? So you're going to have x squared minus x squared. This goes away. So this and this goes away. Okay? Then you're going to have, no, 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 no. This should also be negative because, wait, I put this x here. So with negative 9x. So this and this, negative x squared, and then this and this, negative 9x. Yes, okay, let's continue. So now I have positive 15x, because 4x plus 11x minus 9x plus 44 plus 44 minus 6. Okay, I do that. 15 minus 9 is 6. So 15x minus 9x is 6x, and 44 minus 6, that should also give you 38. So there you go, minus plus 38. This one gives you positive 38. And then you write here, square units. and you box your answer. Don't forget to put your equal sign. Okay? So this was how much? This was the third way or the fourth way? Fourth way. So this was way 4. Now we need way 5. My way 5, I did this, and I divided that, and I divided this, and then I did this like that. Okay? That's how I did my way 5. So this is way 5. So I have A, B, C, D, and E. So then I write here total area equals to area A plus area B plus area C plus area D plus area E. Area A is length times width plus length times width plus length times width plus length times width plus length times width. Okay? Area A, this will be just 2 times x, which will give you 2x. Area B will be 2 times 2. So here will be 2 times 2. Area C will be 2 times 2. So this is 4 and this is 4 plus length times width. This will be x plus 6. So x plus 6, and then this distance will be 4. So from here to here is 4. And then plus length times width for the last one is 2 times. You can do 2 times 3, 3 times 2, it doesn't matter. Okay, so this is the answer to that, this is the answer to that, this is the answer to this. Plus 4x plus 24 plus 6. 2x plus 2x, 6x. 4 plus 4 is 16. 16 plus 6 is 22. And that should give you 38. Did I do that correctly? Let me see. 4 plus 4 plus 24 plus 6, 38. Yes, so I'm correct. Oh, no, no, no. 4 plus 4 is 8. 8 plus 6 is 14, not 16. 14, and then 14 plus 24 is 38. Then I write square units. Okay? Then my last partition, I did it here, and I did it here, and then I did it here. How did I do 5? Okay. All right. So now I have A, B, C, D. So I do total area equals to area A plus area B plus area C plus area D. Area A is length times width plus length times width plus length times width plus length times width. The length of area A is 2, and I'm multiplying with x. So my answer is 2x plus the length of B is 2 and the width is 4. So that gives me 8. From here to here is 4. From here to here is 2. All right. Plus, this should be x plus 6 because from here to here is x plus 8, and then I remove this 2, so that will remain with x plus 6. So x plus 6, and the distance from here to here is 4 plus 3 times 2. So that's I did, plus 4x plus 24 plus 6. 2x plus 4x, that gives us 6x. 8 plus 6 is 14. 14 plus 24 is 38. And there are my 6 different ways of getting the area. And those are not the only ways. There's many ways. So it depends with you how you look at the figure. Okay? Now we have license plates. Okay? And what is it saying there? One state requires license plates to consist of 3 letters. So 3 letters. And how many letters are there in the alphabet? There are 26 letters in the alphabet. Okay. And then 3 numbers. Okay. But you cannot use or. So if you cannot use or, that means I need to subtract 1 here. So I will have 25 different choices for letters. And I cannot use 0. Digits, you can only use 1-digit number. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are 10 digits. We cannot use 0. So that means I'm left with 9 digits. 9, 9, 9. How many different license plates can be created? 25 to the 3rd power times 9 to the 3rd power. You darb to get your answer. Okay. So how much does this give you? If you put this in the calculator, you should get 113,906.25. So 11,390,625 different license plates. License plates can be created. And you box your answer. Okay. Make sure you write legibly. Okay. Jack has been offered a number of internships that could occur in 3 different months, 4 different departments, and 3 different companies. Month, departments, companies. Jack is only available in July. So that's 1 month. But he can go to 4 different departments and he can go to 3 different companies. How many different outcomes? 12 different outcomes. Okay? For the month of July. Question told you July. If the question had told you June and July, then you'll change this to 2. If the question told you June, July, and August, then you would have changed this to 3. But because the question only told you July, you need to put here 1. Okay? I know. Okay, let's do probability and counting. A survey found that about 90% of the junior class is right-handed. Okay, so junior class, right-handed. And if you're not right-handed, then you're left-handed in the junior class. Now, if 90% of you are right-handed, then 10% of you are not right-handed, meaning you're left-handed. And how do I know? Because the whole class lazim equal 100% or equal 1. Okay? If one junior is chosen at random out of 100 juniors, what's the probability that he or she is left-handed? Here. Probability that you're left-handed equals to 10%, which equals to 1 over 10, which equals to 0.1 or 1/10. Right, your answer can come either as a percent, fraction, or decimal. Or you can do it a different way. This is probability of right complement. Probability of right complement. So meaning 1 minus probability of right. Which is 1 minus 90%, which is 100% minus 90%, which is 10% or 1/10 or 1/10. In decimal form, in fraction form, in percent form. Okay, probability of being left-handed means probability of not being right-handed. Okay, so probability of not being right-handed means you take the right-handed and you remove it from 1. Raul bought 24 raffle tickets out of 1,545 tickets that were sold. What is the probability that Raul will not win? Probability of Raul not winning is probability of 1 minus probability of winning. Okay. I think there's 2 ends. That's all right. Just write it like this. Now, how do you get probability of win? How many tickets were there out of the total? 4, 5. And you do that. So what does this mean? 1545 over 1545 minus 24 over 1545. Subtract the numerators. You should get 1521. When you simplify, you should get 507 over 515. You box your answer. Change it to decimal, you should get 984. Round to the nearest hundredth. You're not adding, so approximately 98 hundredths. And then change it to percent. 98%. Okay? At Riverview High School, 120 students were asked whether they prefer a lion or a timber wolf as the new school mascot. What is the probability that a randomly selected student will have voted for lion as the school mascot? Probability of lion equals lion over total. Lion is 78, total is 120. When you simplify this, you should get 13 out of 20. And you box your answer. Then change it to decimal, you should get 65 hundredths. Change it to percent, you should get 65%. In Evans' senior class of 240 students, 85% are planning to attend college. So we have senior. Some want to go to college. Some don't want to go to college. So 85% of them want to go to college. 15% don't want to go to college. How did I get 15? I did 100% minus 85%. Okay? Now, what's the question? What's the probability that a senior is chosen at random and not planning to attend? Probability of not attending will be 15 over 100. If you simplify that, it should be 3 over 20. If you change it to decimal, it should be 15 hundredths. If you change it to percent, it is 15%. Or you will do probability of not going. Probability of not equals to 1 minus probability of going or college. Probability of college. Okay? Which is 1 minus 85%, which is 100% minus 85%, which is 15%. Okay? So there is your answer. 2 different ways. You do the tree diagram or you do that. It's up to you. Drama club. The Venn diagram shows the cast members who are in Acts 1 and 2 of a school play. One of the students will be chosen at random to attend a statewide performing arts conference. Let A be the event that a cast member is in Act 1 of the play, and let B be the event that a cast member is in Act 2 of the play. Find A intersection B. A intersection B is here. So Amy and Alex, or you can write, it doesn't matter who you start with. Either one of them is correct. Alex, Amy. Okay? So this could be your answer. Or this could be your answer. What is the probability that the student who is chosen to attend the conference is a cast member in only one of the 2 acts? So this means probability of A only, okay? And probability I don't want to call it A. Let's call it the way it's been called. Probability of Act 1 or Act 2. Okay? Probability of Act 1 plus probability of Act 2. Okay? Probability of Act 1 only or Act 1 only. 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 Okay? Act 1 only. 1, 2, 3, 4. 4 people. Act 2 only. 1, 2, 3. How many people altogether? 9. Because these are 9 students altogether. Then you should get 7/9. Okay, this will be a repeating decimal. Don't change it to, not unless they change it, then they tell you to round. But because it's repeating, I just left it as a fraction. Larray is playing a game that chooses a spinner. What's the probability that the spinner will land on a prime number? All these numbers are prime. You should know your prime numbers. Oh, they gave you this chart over here. Okay. 29 is here. Where's 29? 29 is there. 53 is here. 41 is here. Why did they give you this? You should know your prime numbers. 47 is here. 19 is here. 37 is here. 23 is here. 41 I already crossed out. 29 I already crossed out. So all the numbers that are here, I crossed them out. So probability is 1 because I crossed out everybody. Okay? The answer to that is 1 or 7/7. Okay, let's write it correctly. Probability of prime numbers will be 7/7, which equals to 1. Okay? Plus. But if I choose everyone, I just choose 1. Don't make your life difficult. Raya is asking 40 people outside the mall whether or not they visited the mall for shopping or Raya asks 40 people outside the mall whether they visited the mall for shopping or for dining. According to her survey, 13 people visited the mall. And these 13 people only did shopping. And then 11 people did shopping and they also had some food. And there were people who just went to eat, and those were 9. And then there were people who just went to the mall to do nothing. They were just there. They did not shop and they did not dine. So maybe they were working at the mall or they just came to the mall to walk around. Okay? All right. So one person will be chosen at random to be interviewed on the local news in the evening. Okay? One person. Find the probability that the person chosen will be somebody who visited the mall for shopping and dining. Okay? So, probability of shopping and dining equals number for both. So you're going to do S intersection D over total. Not over S, over what? Over the total. So that will be 11/40. Okay? So that's your fraction. Then when you change it to decimal, you should get 275, round it to the nearest hundredth. So this is approximately 28 hundredths, and then approximately 28%. And you box your answer. Okay? Make sure you put here or and here or. Okay? Omari has 2 pairs of red socks, 2 pairs of white socks in a drawer. And another drawer has 2 red t-shirts and 1 white t-shirt. If he randomly chooses a pair of socks from a sock drawer and a t-shirt from the t-shirt drawer, what's the probability that he picks red socks and means to dar white socks? So I told you I like tree diagrams. They're easier for me to see. He has red socks, white socks. He has 2 of each. Then he has a t-shirt drawer, and the t-shirt drawer he has also a red t-shirt and a white t-shirt. So he has 2 and 1. So here he has a total of 4, and here he has a total of 3. I read. See? T-shirt, 2 socks, 2 red socks, 2 white socks. Okay. What do I want? Red and white. Red sock and white t-shirt. Probability of red sock and white t-shirt equals probability of red sock plus, multiply probability of white sock. Probability of white t-shirt, sorry. White t-shirt, red sock. Red sock is 2 out of 4. White t-shirt is 1 out of 3. This is half times 1 out of 3, giving me 1 out of 6. Remember, when you're doing probability, do you see the word, what is probability here? What is probability? Your answer cannot be more than 1. Your answer cannot be negative. Your answer must be simplified. All these questions that said, what is probability? You have to check your answer 3 times, 3 different ways. First, you need to check whether it's positive. Second, you need to make sure it is not greater than 1. 3, you have to make sure it is simplified. Okay? Now, if you change this to decimal, I think you should get 0.166. I think. Let me see. 1 divide 6. So, okay. Then you round to the nearest hundredth. Circle that, underline the digits in the thousands place, add, and this should give you 17 hundredths approximately, or 17% approximately. Okay, so there you have your 3 versions of your answer. Phyllis drops a penny in a pond. A penny is a coin. Okay, see, now they didn't tell you it's a coin. They want you to know by yourself that a penny is a coin. And in a coin, you have heads and tails. So this is for penny. And then she drops a nickel. A nickel is another coin. So she has a head and tail. What is the probability that both coins land with tails? Probability of tail and tail equals to probability of tail from penny and tail from nickel. So probability of TP, tail from penny, ضرب probability of TN. And that should give you 1 out of 2 times 1 out of 2, which should give you 1 out of 4, or 25 hundredths, or 25%. Okay? All right. A die is rolled. A die is rolled. That means die 1, 2, 3, 4, 5, 6. And a penny is flipped. A penny is a coin, so head or tails, because it's a coin. Find the probability of rolling a 2 and landing on a tail. Probability of rolling a 2 and landing on a tail is probability of getting a 2 times probability of getting a tail. Probability of getting a tail is 1 out of 2. Probability of getting a 2 is 1 out of 6. This should be 1 out of 12. Change this to decimal. You should get that 83,000th, or, and then round, circle the hundredth. You're not adding, so 800th approximately. And then change that to percent. That should be approximately 8%. Okay? All right. A bag contains 3 marbles, 3 red marbles, 2 green marbles, 4 blue marbles. Okay? So I have 3 colors. I have 3 colors: red, green, and blue. Red, I have 3, green, I have 2, and blue, I have 4. So my total is 9. 3 plus 2 is 5, 5 plus 4 is 9. Okay. Find the probability. Wait. A marble is drawn randomly from the bag and replaced. 9, 9. Replaced. Both marbles are blue. Blue, blue. And you darb. Okay. Probability of blue and blue, but replaced. Okay. So blue 4/9 times 4/9. Okay. That should give me 16/81. We box our answer. And then if I want to change this to decimal, I should get 0.197. 197,000th. Round to the nearest hundredth. Always round to the nearest hundredth if the question doesn't tell you. If it tells you, you do what it says. So this will be 2/10. Okay. And then, or approximately 20%. You box your answer. Okay. So that's how you do that. Make sure replace the decimals will be, the denominators will be the same. And you wanted blue and blue. So there, the number was not changing. All right. The forecast predicts that 40% chance of rain on Tuesday and a 60% chance of rain on Wednesday. If these probabilities are independent, what is the chance that it will rain on both days? Probability that it will rain on Tuesday and rain on Wednesday equals to probability that it will rain on Tuesday times probability that it will rain on Wednesday. So that will be 40 over 100 times 60 over 100. This goes with that. This goes with this. 24 over 100. And that gives me 24 hundredths. And that gives me 24%. When you simplify this, you should get 6 over 25. So you have that or that. Okay? You roll an even number on a fair die. Sample space for die 1, 2, 3, 4, 5, 6. And you have a spinner. You have a spinner, and your spinner is labeled 1, 2, 3, 4, 5. It says 1 through 5. So you have to list all the numbers from 1 to 5. Okay. What's the probability that it lands on an odd number? No. You roll an even number and then an odd number. So probability of even and odd. Even on the die and odd on the spinner. So this will be probability of even on the die multiply probability of odd on the spinner. Even will be, who are my even numbers? 1, 2, 3. 2, 4, 6. So that will be 3 out of 6. Who are my odd numbers? 1, 3, 5. So that will be 3 out of 5. That should be 9 out of 30. Okay? And then you simplify. If you simplify that, you should get 3 over 10. Because the greatest common factor is 3. So divide by 3, divide by 3. Should get 3 over 10. That's your fraction. Your decimal will be 3/10, and your percent will be 30%. Or, okay? An ace is drawn from a standard deck and is not replaced. Then a second ace is drawn. So aces come in hearts, come in diamond, come in clover, and come in spade. Okay? And it is not replaced. So probability of an ace and ace, but not replaced. So this is dependent, which is equal to 52, 51. Not replaced, that. Not replaced, the numbers reduce, okay? How do I know I have second? Because I have 2. Second means 2, so that's why I made 2 fractions. and that will be 12 over 52 dot 51, 2652. 2652. And then you simplify, you should get 1 over 221. And then that's your answer. Okay? In a bag of 3 green, 4 blue. Okay, so green is 3 and blue is 4. A blue marble is drawn and not replaced, and a second, so 2 fractions. Total is 7. Not replaced, 7, 6. Okay, you're darbing probability of blue and blue. It says there. The first one is blue, the second one is also blue, and not replaced. How many blues? 4. If I don't replace it, 3 will be in the next selection. This is 12 over something, 42? Yes. When you simplify this, you should get 2 over 7. Why am I writing horizontally? 2 over 7. Then change this to decimal. That should be 0.285. Round to the nearest hundredth. That should be approximately 29 hundredths. Change that to percent. That should be approximately 29%. Or. Okay? All right, let's move on. You roll 2 fair die. Read the question. Determine whether the events are independent or dependent. Explain your. You roll a 2 fair die and roll a 5 on each. Independent. These 2 dice don't have nothing to do with each other. This is independent. One is in your right hand, the other one is in your left hand. You throw them at the same time. Whatever you get on the left has nothing to do with whatever you got on the right. Whatever you get on the right has got nothing to do with whatever you get on the left. So independent. Okay? So explain your reasoning. Die 1 has nothing to do with die 2. They are independent. Die 1 has nothing to do with die 2. They can happen at the same time. They can happen at the same time. So they are mutually exclusive. So they are mutually exclusive. No, they are mutually exclusive, not mutually exclusive. Mutually exclusive cannot happen at the same time. They are not mutually exclusive, so they are independent. Yes, not mutually exclusive. Okay? Mr. Haynes places the names of 4 students. 4 students. Who are the 4 students? He has slips of paper. So here he has Joe. Here he has Sophia. Here he has Hayden. And here he has Bonita. From these, he intends to randomly select 2 students to represent his classroom. 2 students. See? At the robotics convention, he draws the name of the first students and sets aside, not replacing. So dependent, 4 and 3. What? Then he draws the name of the second student. What's the probability he draws Sophia? There is only one Sophia. And then Joe. There is only one Joe. And Udharp. So now let us write this correctly. Probability of Sophia, then Joe, is probability of Sophia times probability of Joe. But remember, it's without replacement. So here is 4, here is 3, 1 Sophia, 1 Joe. And our answer should be 1 out of 12. You boxed it. Okay? You want to change it to decimal? 1 divide 12. So repeating decimal. Round it to the nearest hundredth. And that should be 8%. So or. Remember you're rounding, so make sure you write approximate. Okay? All right. A card is drawn from a standard deck. Uh-huh. I see the word standard deck. I think of the rakam. Ithnain uhamsin. So 52. A card is drawn from a standard deck of playing cards and not replaced. And we have 2 of them. 52, 51. Find the probability that the first card is a jack of spades. Jack of spades is only one of them. So there is 1 over here. There's only one jack of spades, like this. It has the harf J and this ishara. And then the second card is black. So black cards, there are 26 of them. You have spades and you have clovers. I don't know how to draw this. Okay. Now there's 13 spades and there's 13 clovers. So altogether there's 26 of them. Now what is the question? We are not replacing, okay? Probability of jack of spades and probability of a black card. And without replacement, okay, is equal to probability of jack multiply probability of black card. And because we are not replacing, we are going to reduce our denominator. So this is 1 over 52. And this one here will be 51. And there's 26 black cards. So this will be 26 over 2652. And that should give you 1 over 102. Okay. Intramural sports. The table shows the color and number of jerseys available for the intramural volleyball tournament. When I add these, I should get a total of 70 jerseys, excuse me. If each jersey is given away randomly, what is the probability that the first and given away means not replacing? You've given it away. It's not coming back. So you're not replacing. What's the probability that the first and the second jerseys, 70 and 69, because you said no replacement, are both red? So probability of red and red without replacement equals probability of red multiply probability of red. Now, the first red is 25, the second one is 24. And that should give you, or that should give us 600 over 4,830. And when you simplify this, you should get 20 over 161 out of 20 out of 161. And there, two frequency tables. Okay. So you should know these ones are called marginals, and these ones are called joint. So you should know where you have marginal and joints frequencies, okay? The two-way frequency table compares data about students in the class who completed or did not complete homework. So my first variable is homework. My second variable is passing, okay? And those who passed or did not pass an exam. How many students completed their homework and passed the exam? Completed and passed, they are meeting here. So 18 students completed their homework and passed the exam. And because it is here, it is a joint frequency. So joint frequency. Why is it joint? Because you use both homework and complete and passing. So you're joining this row and this column. So that's why. So joint frequency is your answer, and 18 students is your answer. So you should have two answers for this question. Raquel surveys 160 people to determine if they prefer drama or comedy movies. So we are comparing movies and we are comparing gender. Those are my two variables. So what type of movies? Drama and comedies. And here, what type of gender? Male and female. And you should always have total. Okay? All right. The relative frequency table shows the data collected from the survey. Determine whether the gender is independent. How will you find independent? You're going to do the total of row 1. You're going to multiply the total of row 1. You're going to multiply with the total of column 1. Here you're going to do the total of row 1. You're going to multiply with the total of column 2. Here you're going to do total of row 2. You're going to multiply with total of column 1. Total of row 2. You're going to multiply with total of column 2. Okay, let's see our numbers. Total of row 1, 37.5%. You're going to multiply total of column 1, 59.4%. Total of row 2, 62.5%. You're going to multiply with 40. No, this is column 1. So you're going to multiply with 59.4%. Total of row 1, 37.5%. You're going to multiply with total of column 2, 40.6%. Total of row 2, 62.5%. Total of column 2 is 40.6%. When you multiply, let me use green. When you multiply the percents, you'll get a decimal. So you have to double that decimal with 100. So you will get 59.4%. I don't even have to continue. Why should I continue? This number is already different from this number. So they are not independent. I don't even have to continue. Okay? But let's just do, because I want you to see something else. So this one will be 15.2%. And then this one will be 7.1%. And then this one will be 25.4%. In the calculator, make sure you do 37.5% times 40.6%. Then you'll get a decimal. That decimal you have to multiply by 100 to give you this percent. Okay? All right. Now add your columns. Not another color. Okay? If you add these two numbers, you should get 37.5%. If you add these two green numbers, you will get 62.5%. If you add these two blue numbers, you should get 100%. If you add these two green numbers vertically, you should get here 59.4%. And here you should get 40.6%. Now, when you are explaining about independence, you have to look at these numbers that I have circled here in blue and these numbers that you have done here in green. If they are not the same, then they are not independent. Okay? So then you will write the joint frequencies are not equal or are not the same, are not the same. So the variables are not independent, are not independent. Okay? All right, we move on. For a business report on technology use, Danielle asks a random sample of 72 shoppers whether they own a smartphone and whether they own a tablet computer. His survey shows that, so I'm going to draw a Venn diagram. I keep saying this is the best way to process your data. So we have smartphone and we have tablet. And there is 72 of you. Okay. So his survey shows that out of 51 shoppers who own smartphones, 9 of them also own a tablet. How do I get the number here? I do 51 minus 9. 51 minus 9. And that should give me 42. So 42 people own smartphone only. Okay, let's continue reading. While out of the 21 shoppers who do not own smartphones, so that means they own tablets. So here I will do 21 minus 9. 21 minus 9. No, let me read first before I make that conclusion. Okay. While out of 21 shoppers who do not own smartphones, 15 of them do not own tablets either. So 15 are here. Then what is 21 minus 15? 6. That's where I do that. So I will do 21 minus 15 and I will get 6 and I will put it over here. Those are the people who own tablets only. Okay? All right. And the people who own tablets are 15. Okay? So, how do I know I'm correct? I should add 42 plus 9 plus 6 plus 15. If I don't get 72, I am wrong. So, 42 plus 9, that is how much? 51. 51 plus 6, that is how much? 57. 57 plus 15, that is 672. So I know my, what is it? My Venn diagram is correct. 51 minus 9 is 42. Okay? So that's how you fill your Venn diagram. Now let's continue. Find the conditional probability. So this is new. You have to get Kanun for this one. Find conditional probability. So the probability that you have a tablet given that you had a smartphone equals to probability of smartphone and tablet over probability of smartphone. So this is probability of smartphone and tablet Taksim probability of smartphone. Probability of smartphone and tablet is 9 out of 72 out of the total. Divide by probability of smartphone should be 51 out of 72. Because I want the whole circle for smartphone. Okay? So then this becomes keep, change, flip. So this will be 9 over 72 times 72 over 51. This goes away. So you'll have you will have 9 over 51, which is 3 out of 17. And you box your answer. Okay? Paz asks a random sample of seniors at her high school whether they own a car and whether they have a job. The results of the survey are shown in the two-way relative frequency table. Paz says that the conditional probability that a student has a job given that she has a car is 46 and 7/10%. Do you agree? Justify your argument. Okay. Probability that you have a job given that you have a car. What am I doing? Equals to probability that you have a car and job over probability that you have a car, which means probability of car intersection job divide probability of car. Probability of car and job is 29%, so 21.9%. So 21.9 over 100, and you're dividing with probability of a car, which is that. Probability of a car is 34 and 4 over 100. Keep, change, flip. So that becomes 21 and 9 over 100. Multiply 100 over 34 and 4/10. This goes away. You should get 634. No, 636. 636. Round to the nearest hundredth. So you should get 64. Change it to percent. Should be approximately 64%. Now, these numbers are not the same. So, do you agree? I disagree. I disagree. Here is my justification. My work is my justification. All this, okay? You should have gotten, I disagree because the conditional probability should be 64% and not 46.7%. Okay? 46 and 7%. There. All right, that's it for today. I'll continue tomorrow. Okay. 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 Okay.